How's it going, everybody? And welcome back to our Cisco Enterprise series. We're continuing our section of building out the MPLS core in our MPLS VPN service provider. What we're going to be discussing in this video in the very beginning is just kind of a recap of where we are in terms of the build out itself. And then we're going to talk about the next step in this video, which is going to be the BGP piece for getting all of the routers and switches, or I should say all the routers, the provider routers and then the provider edges on the outside of the network, on the edge, get them configured to do BGP. So I want to go ahead and do a quick recap so that everybody's on the same page here. So MPLS and MPLS VPN are two logically different things. So I want to reiterate that again. The first being the MPLS itself is the building out the service provider core. So everything inside of this big rectangle here is the MPLS provider network, and anything that connects to it is considered the VPN. So the MPLS core, which is the base of it, is IGP, some sort of link state protocol like OSPF or IS to IS. We're using IS to IS in this case, level 2 everywhere, all in the same area. And then what we're doing is we enabled LDP, Label Distribution Protocol, in the previous video to get that working. Now that we have a labeling mechanism in the core, that allows us to build the transport label. The transport label is what gets you from your ingress PE to your egress PE. That's what LDP's job is to do. When we go to, after we get BGP deployed and have that working, when we go to connect 64, 65, 66, and 46 to the outside world, what we're going to be doing on those connections on the PE to CE interface on the provider edge side, so gig 2, gig 002, gig 4, gig 3, gig 2, gig 2, all of that, we're going to be putting those interfaces into a VRF. We haven't covered VRFs yet, so just be knowledgeable that they're coming. We just haven't covered them yet because they are VPN specific for this particular use case. The BGP process, we're going to be introducing a new address family to you, which is going to be the VPNv4 address family. There is one for IPv6, known as the VPNv6. We'll be covering that later. VPNv4, that address family, its job is to associate the VPN label, because remember there's two labels in the label stack. You got the transport label and you got the VPN label. The VPN label is allocated via BGP whenever a route is learned by a provider edge router. The provider edge router will go ahead and allocate a label for any routes that are learned by the customer edge routers. In this case here, when we get to do BGP, BGP will be the first routing protocol we use as a PE to CE routing protocol, and that will be where we'll come into play and see how that correlates. You can use all the IGPs as well as static routing, so we'll be testing those out as well. For those of you that are studying for the lab exam, or you are studying for your NRC exam, then my guess is they're going to be doing just a BGP peering. I don't remember them doing an IGP peering when I took the lab. I remember it being BGP only. But at the end of the day, that really doesn't matter. You want to be knowledgeable on all of the different variations because you can do all three. Right? You can do BGP, you can do IGP, and you can do static routing. That's what I mean by all three. So just be knowledgeable on what that is. So the lab is probably only going to test you on BGP. So when we come to things like that, that's going to be the key protocol we're going to be testing out of the gate. Now, we're going to have a non-VRF aware BGP process spun up on the PE routers, and then XR47 and R32 are going to be our route reflectors. And we're doing dual route reflector simply for the fact of it's redundant. Right? And I wanted to show you guys how to do both. It's very, very simple. You remember from previous videos in BGP where we went ahead and did this, and we did route reflection on 61 and 43, we ran into some problems. I think it was XR specific. So I ended up turning off route reflection here, and just did reflection here, and it seemed to stabilize things. So we're going to do the exact same thing here, except for there's some next hop processing updates that get changed when we go to MPLS and use a labeling mechanism versus using straight IP in the core. We'll talk about that in a little bit later. So we're going to be forming a VPNv4 BGP peering from XR47 or 32 to 64, 65, 66, and 46. We'll get that all stood up, and the process is actually going to be very, very straightforward. It's not going to be very complicated configuration-wise. We'll be introducing a new address family and going through that process, but it's basically, there's really nothing more to it than that. We're just turning BGP on, and you won't see anything really happening, right? You won't see any routes learned. We would have to get this environment back up and running, and then we'd have to do a BGP peering from 58 to 64. That will come later on, and then I will have to obviously spin up these routers here in order to get route propagation to work and things like that. And the same thing over here. You know, we'll have to get these routers up and running, and then this environment stood up so that we can actually get route propagation to happen, things like that. So what I will probably do in the short term, until those are some bigger sites, what I will probably do is I'll get these sites up and running, 37 and 38, so we can see what route propagation looks like and see how that comes into play. So it'll be fairly straightforward for the most part when we get started, but just one of those things where you just want to be cognizant of what's coming. And so just to recap one more time real quick, it's from the 3-layer cake that is MPLS, and then the 2-layer cake that is MPLS VPN. You've got IGP, LDP, BGP, VPNv4 for MPLS core. For the VPN piece, you've got VRF and PE2CE routing. So all of those 5 individual steps are needed in order for this to work. Remember, there is no router MPLS. MPLS is a collection of technologies that provides a service to the customer. So what I'm going to do is I'm going to go ahead and get out of the way. I'm going to pull up Secure CRT, and you and I are going to go through and get this configured. So I'm going to start on iOS, and then I will add an XR later on. And it looks like XR is returned. It looks like it's stable. If we do a show run, it does respond the way we want to. And if we do a show MPLS forwarding table, forwarding, we can see that the label values have been updated. Same thing with 46. Log into him real quick. Show MPLS forwarding. We can see that 46 has been updated. We see the POP label, all that good stuff. All right. Now that we've got that process under control and we're squared away, I am going to start on the route reflector on 32. And if we look at BGP, do show run pipe section BGP, BGP is not running yet. Now, this will also correlate to what they refer to as the BGP free core. So router 30, router 31, they're not going to run BGP at all. They're not going to be BGP aware at all. They're going to be IS to IS and LDP aware, because they happen to be, but they're not going to be BGP aware. So there's a common question that I'm asked when I start breaking down MPLS VPNs is, do I need to do route reflection? And the answer is no, you don't have to do anything. What you do need to do is satisfy the iBGP full mesh requirement. Remember what we talked about in the beginning of the BGP section is in order for iBGP to work correctly, you don't propagate routes beyond your directly connected neighbor. So if 64 and 46 are iBGP peered and 46 and 66 are BGP peered, I advertise a route to 46, 46 does not advertise it to 66. So in order to satisfy that requirement, we need to form peerings with everybody, 64 to 65, 66, and 46. that would be a full mesh peering. So that would relieve all of these routers here completely BGP free. So you don't need to run BGP in the core if you don't want to. Now in this environment here, it's relatively small, so it's not that big of a deal. We could pull off a full mesh of peerings if we wanted to. That would work. In this case here, I'm going to turn route reflection on so you guys can see it, because more than likely that's what you're going to get tested on. Not saying that's for sure, but what I would do is I would know how to do both. So that's something that you can test out. In this particular case, we already have tested that out up here. I believe it is this one here. So we've done a full mesh of peer. This one up here, we did a full mesh of peerings, 26 to 27. So we peered everyone to everybody else. The only difference is we peered in the IPv4 address family and not in the VPNv4 address family. That is the only difference between what we're doing, what we did here, and then using route reflection down in the MPLS core. So if I wanted to, I could do all the PE routers could be fully meshed to each other, and that would be the same thing as doing it up here, except for just doing a different address family. That's the only difference. Now with that being said, let's go ahead and dive into this config. It's not very difficult to follow along, but I just want you guys to be cognizant of what is going to be going through as we do this. So let's go ahead and go to global config, and we're going to be using AS10. So it's going to be router BGP 10. And the first thing that I want to do is I want to turn off any type of automatic peering capability. So I'm going to type in no BGP default IPv4. So I won't automatically try to form a IPv4 unicast peering. And what I'm going to do is I'm going to add in something that you haven't seen me demonstrate yet. You've seen peer groups, and you've seen the long way of doing all of the peerings, right? You've seen the full mesh and the route reflection variation, but you haven't seen the template yet. The template is going to be a way of, it's a peer group type of configuration, but it is not a peer group. So what I'm going to go ahead and do is I'm going to type in here template, and there's two different types of templates. You have the peer policy and the peer session. The peer session, this is going to be your remote AS, update source, loopback 0, password, all that good stuff. The peer policy is going to be your next top self, your route reflector client, things like that. So I'm going to type in peer session and give it a name. I'm going to come in here and just type in session, and then hit the enter key, and then underneath here we have our options. We're going to type in remote AS of 10, update dash source loopback 0. I'm not going to put in here any other configurations like password or anything like that. I could. I can say log, neighbor changes, things like that. There are other capabilities as well, eBGP multi-hop, disable connected check. I could put the cluster ID in here if I wanted to, stuff like that. So now that I've got that done, I'm going to do the template peer policy and type in policy. And underneath here I have my route reflector client option. There's other options down here too, soft reconfiguration inbound if you wanted to. You have send label, but we're not doing anything with IPv4 labels, anything like that. We'll talk, this is definitely service provider where you can do a network and an MPLS label to the peer. Next hop self, I don't need to worry about that. I don't need to worry about next hop unchanged. This would be for doing things like inter AS option C. So we'll talk about that more in the service provider series, but there's another one in here, AS override and ASN. We'll talk about those down the road, but for right now, that's all we need to really dig into. So I'm going to go ahead and exit out of that, and I'm going to type in neighbor, and this is going to be 10.0.0.64. I'm going to come down here and do a question mark, and what I'm looking for is this inherit command. This inherit command allows me to apply a policy. I'm going to inherit, and it's going to be peer session and session. Now you can name your sessions as well. So if you wanted to if you needed to provide uniqueness to your sessions, you could do that as well. So you can create a session for this, you can create a session for that guy, you can create a session for that particular peering. that have different attributes associated to them. So sometimes it makes sense, sometimes it doesn't. So it's up to you on how to determine that. All right, so I'm gonna hit the enter key, and then I need to go underneath here, address family, and then it is going to be, we have to turn the IPv4 address family on, but we're not going to activate any peerings underneath of it. So it's going to be IPv4 unicast. I'm going to type in address family VPNv4 unicast. So now that I'm underneath here, I'm going to type in here, hit the up arrow a couple times to this guy. I'm going to say inherit peer policy and hit the enter key. So let's activate the neighbor first. I knew that. Activate. So now do show run section BGP. So as you can see, we have our peer session. So remote AS10, log neighbor changes, update source loopback 0. We have our peer policy. We have route reflector client. We've configured it. We enabled the IPv4 address family, but there's no peerings configured underneath of it, only VPNv4. So send community extended. This is another command you'll have to remember. This happens automatically with iOS, and this is what allows us to send the route distinguisher and the route target information with the updates. Now, what's interesting about this is we're going to do something very, very similar when we get into VXLAN and how we do the VXLAN with eVPN with the BGP as the control plane. Nexus doesn't do this, add this send community extended command by default. So you have to remember to enable it or else it won't send the updates. I will actually show you what a demonstration of that looks like. So we've got that. So let's go over to 64. Go to global config and type in router BGP10 and type in no BGP default IPv4, neighbor of 10.0.0.32, remote AS of 10, update source loopback 0, and then address family VPNv4. We're going to go ahead and activate, and it's up. So there we go. So do show run pipe section BGP. So even though I didn't go in and turn on VPNv4 by default, I'm sorry, IPv4 by default, as soon as you turn this on, it automatically enables IPv4. Why? Why do we care? Well, the simple answer is this. VPNv4 is a sub address family identifier of IPv4. So IPv4 is your main address family. And then there's going to be a bunch of sub address families. You have, if you want to do IPv4 multicast, if you want to do IPv6 multicast, if you want to do VPNv4, if you want to do any of your multicast distribution trees, MVPN, stuff like that. Anything that has IPv4 communication inside of it, you need the address family IPv4 enabled on it in order for it to allocate the sub address families. So VPNv4 is a specific address family for doing MPLS VPNs. Without IPv4 turned on, you're going to have problems with it. Not saying it's not going to work. Feel free to test it out and see what it does, but in my experience, it makes more sense. It's going to do it automatically, so whatever iOS does by default is probably there for a reason. So I wouldn't mess with it. So now we have that. I'm going to basically do this. Do show run section BGP. I'm going to take this config and I'm going to copy it and paste it into 65 and 66. As you can see, this is going to be my CCIE pro tip. Now I get to go back to 32 and I get to exit out of here, and what I'm going to go ahead and do is I'm going to type in this command right here, but I'm going to change this to be 65 and 66. And then address family VPNv4, I'm going to go ahead and do this command for 65 and 66. And then I'm going to go ahead and apply this one for both. Now what's interesting is it's going to reset it. And the reason why it's reset it is because there was a change to the policy. I added route reflector capability. So I changed the capability exchange between the peerings. The capabilities exchange is going to be a bunch of capabilities, pardon the pun, that are going to be negotiated between the BGP peers, like route refresh, route reflector capability, things like that, that are going to be sent back and forth to help optimize the BGP experience. So if you're setting it without route reflector and then you add it, it's going to basically resync the connection. All right, so now that I've done that, if I do, let's jump out of global config and do a show BGP VPNv4 unicast, and then we have to say all and then summary. Right, I have 3 peerings up. Now the reason why I have to say all, if you look at unicast, it's like, okay, which VPN routes do you want to look at? Do you want to look at all the VPN routes that you've learned from every one of your route reflectors, regardless of the VRF? Do you want to look at a particular route distinguisher for a specific VRF, or do you want to look at a specific VRF, period? So that is essentially where that comes into play. Now, I don't have any VRFs created. I don't have any route distinguishers defined. So therefore, I really can't look at either one of these yet because there's nothing configured for either one of those. So I have to use the all command temporarily until I have VRFs configured. Now, there's a common question I get. When will we start to see these zeros turn into other things like 1, 2, 3? Well, the answer to that question is once we form PE to CE routing, we will. Until we do that, you won't see anything show up here. All we've done right now is built a control plane. So until we go through and we've finished that configuration, you won't see any routes come through. So again, we're at step 3 out of 5, right? We're at the last step of the MPLS core. Once we're done with this, and we have 46 peered to 32, and then we go to 47, and we apply 46 and then 64 through 66. Once we have all that configured and we have all of our peerings up and everybody's happy, then we'll be done with the MPLS core. Then in the following video, we'll be discussing what the VRF is and why we need it. And then once the VRF is created, then the PE to CE routing process is actually relatively straightforward. I'm going to spin up 37 and 17 and 38 and 18, and we'll get those to propagate some routes, and we'll do some route exchange, and then you'll start to see some routes show up. But before we do that, you're not going to see anything show up. We're building the layer cake, right? We're on layer 3 of 5 right now. So with that being said, let's go ahead and jump over to 46, and let me do a show run type section BGP. As you can see, I've added some configuration, and everything looks pretty good. So the question is, can I add this send community extended underneath the policy and get rid of it out here? Let's try. I honestly don't know. Router BGP 10, and then underneath the policy, we're going to say send community extended. You can actually do the command both. It'll send both standard and extended, so I'll just type in both. And if we exit out, and I do show run section BGP, the policy has been updated, but we still see it. So if we were to go underneath the address family VPNv4 and say no here, will that affect anything? It shouldn't. It won't even let us take it away. It's there regardless if we want it to be there or not. So hopefully that answers your question. So there we go. Anyway, we're going to go ahead now and we're going to add in neighbor. We're going to add in 46 like that, and then underneath that we're going to hit the up arrow. We're going to go ahead and say activate. Then we're going to hit the inherit peer policy. Now 46 is not configured to do anything yet, so we're not going to see a whole lot of anything. So let's go ahead over here We'll log in, go to global config. I type in the router BGP10, and then I have to turn on the address family IPv4 unicast first. Then I have to type in address family VPNv4 unicast. And underneath here, we can associate VRF specific configs if we wanted to, stuff like that. I'm not too terribly worried about those things. So I'm going to go ahead and I'm going to exit out of that. And I'm going to go ahead and begin my peering process. I'm going to type in neighbor of 10.0.0.32. Now there are, I did mention this in a previous video, where you can go ahead and do a session group and an address family group if you'd like to do so. That's an option here as well. I've already demoed that, so I'm not going to re-demo it again here. So I'm just going to type in here remote AS of 10 update dash source is loopback 0, and then I'm going to go ahead and say address family VPNv4 unicast, and that's literally all I have to do here. There's really nothing more to this process that I have. Now if I was using group configuration like AF group, I would use inherit configuration from the address family from a group. That's pretty much that. So there's other options that are available to us if we'd like to play around with those things, but right now we don't need to worry about that. So we do show config, fairly straightforward configuration, right? I'm going to go ahead and say commit, and then after a moment or so we should see 32 and 46 form a BGP peering. There it goes. I go back to 32 and I jump out of global config and do a show BGP. I have all 4 peerings up now. Fairly straightforward process. Alright, so we're going to repeat the process for 47, but 47 is going to be a route reflector this time. So I'm going to go to global config, router BGP10, and here I am going to use a session group because it makes more sense, right? Use the session group where you're going to get the biggest bang for your buck on your time and effort. So in this case here, I'm going to use a session group, and I'm going to call this guy here VPNv4, and I'm going to come under, hit the enter key, and I'm going to say remote AS is 10 update dash sources loopback 0, all that good stuff. Again, going back to the peer session, and then I'm going to use the AF group is going to be VPNv4 for the address family, and it's going to be VPNv4 unicast. Now, one thing that I'll have to do, and I'll type in here route dash reflector client. One thing I have to do here, show config, is I haven't turned on any address families. So I need to turn on IPv4 unicast, and then address family VPNv4 unicast. Okay. Now that I have that, I can type in neighbor, and I can specify 10.0.0.46. I can say neighbor 10.0.0.46. I can say use session group, and the session group is going to be VPNv4, and hit the enter key. And then I can say address family VPNv4 unicast, and say use AF group VPNv4. Simple as that. Now if I do show config, I can simply repeat the process a few more times. So I'm going to come over here, and I will say this is going to be 64, and then I just copy and paste this information right here in. And then I hit the up arrow a couple times. I do 65, copy paste, and then 66, copy paste. So I'm going to do a show config again just to verify everything's looking correctly. 46, 64, 65, 66, perfect. Let's go ahead and commit that config. Now since I just configured 46, I should be underneath the config still. If I do a show do, actually this should be right there, should be enough. So let's go underneath here, and we'll do 47, and then we'll go and do this. Commit. So that should form a peering here momentarily, assuming I've done everything correctly up to this point. There it goes. It just takes a little bit longer than I'm willing to wait. So do show BGP VPNv4 unicast. In this case here it's going to be summary. I have my peering up. Perfect. Alright, now 64, 65, and 66 are all going to be the exact same config. So let's do show run section BGP. I have to come underneath here and just type in this guy right here. I will change this out a little bit. So what I'm going to do is I'm going to show you again the CCIE pro tip. Pull out Notepad, and I'm going to copy all this config right here into Notepad. We're going to new tab, and then all I'm going to do is change this to be 47. 47. Just like that, and then take all that information, copy it back into here, and paste. Oh, router BGP 10. Same thing with 65. Router BGP 10, paste, and then 66. Just like that. Now 47 should start forming peerings here momentarily with 64, 65, and 66. And it does. So if I jump out of here and do a show BGP VPNv4 unicast summary, I have all my peerings up. So that is a CCIE pro tip. If you can optimize your configuration at any point in time, I obviously recommend that you do that. It makes a lot of sense to take advantage of Notepad, especially if you're legit looking to take the lab exam. You're going to want to optimize your configuration whenever you can. Do I think you need to have all the syntax memorized so that you can literally just like look at your tasks on one screen, look at your topology on the other, and then have Notepad pulled up and just sit there and type it all out? I mean, if you want to get that into it, be my guest. But I am more of the let's build out one device. So if you're doing like an MPLS deployment, you build out one device, you get it fully configured, and then you copy that into Notepad, you make your little adjustments, you paste that configuration into another device, you're up and running. Same thing with DMVPN. If you have a large DMVPN deployment, I would do one spoke and then copy and paste the config into others. So it optimizes your time. Optimize where it makes sense. So as of right now, we have everything up and running and we're in good shape. So in the next video, we're going to be discussing MPLS VPN, so the VRF. So we're going to be adding the VRF and all that good stuff that goes along with it. So in between now and the next video, I will have these devices up and running and fully configured. I'll figure out what IGP I want to use for internal routing, and then we'll do BGP peerings to 64 and 65 so we can see what a basic MPLS VPN is going to look like. It'll take some time. That won't be happening in the next video, obviously. It'll be when we get to PE routing, but I'll go through that process. So if you guys have any questions, comments, concerns, feedback, drop that in the comment section below. If you haven't already done so, please like, share, and subscribe, and I'll catch all of you guys in the next video.